Good afternoon, y'all. It's time to do our benchmark review. Just pay attention. You should be all set to go. Our first note is that speed is distance divided by time. Speed is distance divided by time. And my example of how to calculate speed is this. If David skated down a ramp that was 200 feet long, he traveled down a ramp in 10 seconds. What was David's speed as he skated down the ramp? Well, I know that his distance is 200 feet. His time is 10 seconds. So I know that his speed is going to be 200 divided by 10, which is going to equal 20 feet per second. Remember our units. I want you guys to do practice question number 1. At a track meet, Devanti raced the 400-yard dash. He ran the race in 10 seconds. What was Devanti's speed? And don't forget your units. Our second note for the day. We will use a line graph to measure something over time. Again, when something is over time, we use a line graph. So if a person is moving, there is a constant speed. Their speed is constant. So when I look at the distance from John's house, when I know from point A to B or from here to point A, I know that he is moving away from his house. His speed is constant. And if a person is stopped, the slope of the line on the graph is flat. So I know from point B to C that the slope is flat. So here John is stopped. And I want you to answer practice question number 2. During which periods was John moving? Remember, there are 2 right answers here. Is it A to B, B to C, C to D, or D? None of these. Our practice question number 3. During which of the following interval was John's speed 0? So when was he stopped? Was it A to B, B to C, C to D, or D? None of these. Our note 3. Net force is the resulting force after we add or subtract. So I know that we are going to add forces going in the same direction, and we are going to subtract forces going in opposite directions. So I know that when I look at this block, I have arrows all going in opposite directions. I have one pointing down, one pointing up, one pointing to the right, and pointing to the left. So I know that I'm going to be subtracting here because they're going in opposite directions. So let's take a look at my net force up and down. I know that I have 40 newtons down, so I would do 40 down, and I know I'm subtracting the 10 up because they're going in opposite directions. So 40 minus 10 is going to be 30 newtons, and I know it's going to go down. Now let's take a look at the net force side to side. I know that I have 30 newtons going to the left, so I know I'm going to be doing 30 because it's bigger, minus the 20 newtons going to the right. So I know that 30 minus 20 is going to be 10, and I know it's 10 newtons going to the left because it's the bigger force. So 10 newtons going to the left. I want us to go to practice question 4. If James applies a force to the airplane that he tosses in the air, but the wind blows and pushes it back, calculate the net force of the toy in the airplane below. Is it 26 newtons to the right, 15 newtons to the left, 11 newtons to the right or 11 newtons to the left. I want you to explain how you know what direction the plane will move. Practice question 5. In the picture below, solve the net force of the object. Show all of your work. So I want you guys to find the net force going up and down, and the net force going left to right. Which force is bigger? You'll have to subtract for this. And our final note of labeling forces. I know that in terms of forces, we have 4 types of forces. We have gravity, our normal force, our applied force, and friction. So if this guy is moving a piano, I know that gravity is going to be my force pulling down. So I want you guys to write that in the definition of force. I know that gravity pulls downward. In order for the piano not to sink to the center of the earth, we're going to need our normal force. So I know my normal force pushes upward. This is going to be my normal force going up. In order for the man to move the piano, he's going to have to apply the force in the direction which he's moving it. So I know that his applied force is going to the right because he's pushing it to the right. And I know that what makes moving the piano heavy is because of friction. And friction is going to oppose his motion. So as he's moving it to the right, our force of friction right here is going to be moving to the left. It opposes his motion. It makes it hard for him to move. And our last question. Practice question 6. The box below is sliding down the ramp. Draw the 4 forces acting on the box. So there should be a force going down, a force going up, a force going right, and a force going left. Which forces are these?